Hello buddies, this is Sidhu, Senior Lecturer in Chemistry, Chaitanya Educational Institutions, Gosala. So today we will discuss about another important subtopic in chemical equilibrium, that is ionic equilibrium. So this ionic equilibrium is very important for NEET examination, and we shall see some important models, important problems in this chapter. Let's go. So this question is about theories of acids and bases. So I am giving assertion reason format question. So let's see the question. What is the assertion they have mentioned? The amphoteric nature of water is explained by Lewis acid-base theory. The amphoteric nature of water is explained by Lewis acid-base theory. The reason is water acts as acid with ammonia and also as a base with the H2S. In the light of above statements, choose the correct answer from the options given below. That we know. First option is both assertion and reason are correct, and reason is the correct explanation. And second option is both assertion and reason are correct, but reason is not the correct explanation. And option C is assertion is correct, but reason is wrong. And option D is assertion is incorrect, but reason is correct. Now, first of all, we know that water is an amphoteric substance. Why? Here, water is amphoteric because it accepts the proton, also donates the proton. So, here water accepts the proton and convert into H3O plus. So, it is a Bronsted base which accepts the proton. Water also releases H plus ion or donates the H plus ion. Therefore, it acts as a Bronsted acid. So, water acts as Bronsted acid as well as Bronsted base. But what is the assertion they have mentioned? The amphoteric nature of water is explained by Lewis acid base theory. Water is a Lewis base. Why? It is a Lewis base. Water is a Lewis base because water has oxygen. This oxygen has two lone pairs. So, therefore, water acts as a Lewis base, but water never acts as a Lewis acid. So, therefore, the amphoteric nature of water is explained by Bronsted-Lowry theory, but not Lewis theory. Therefore, obviously, assertion is wrong. So, assertion is incorrect means we have only one option, that is option D. Let us see the reason also. Water acts as an acid with ammonia because water is more acidic than ammonia. When water reacts with ammonia, what it produces? It produces ammonium ion and OH minus ion. That means water loses proton to ammonia. Therefore, water acts as an acid. That statement is right. And base with H2S. Yeah, water acts as a base with H2S. Therefore, it produces H3O plus and HS minus. That means here the amphoteric nature of water is explained by Bronsted theory. The typical example is water donates proton to ammonia and accepts proton from H2S. Therefore, reason is correct. Unfortunately, the assertion is incorrect. Therefore, the right option is D here. Let's go for the next question. The next question is about the calculation of pH of strong acids and bases. Now, look at the question. They have given pH of 0.01 molar barium hydroxide is. The first thing every student should know is whether it is a base or acid. That you need to know. The next one is they have given molarity or normality. That you need to know. These are the 2 points to solve the pH of strong acids and bases. First of all, here look at the problem. The pH of 0.01 molar barium hydroxide. It is an acid or base. Barium hydroxide is a base. Obviously, for base we need to calculate pH or pOH. We need to calculate pOH. Students in a hurry mode, they do pH and directly go for the option. Therefore, be careful. So, we need to calculate pOH first. What is its pOH? What is its pOH? That is actually the pOH formula minus log OH minus ion concentration. We take normality. Okay, not the molarity generally. For OH minus normality equal to molarity. But here, if the other bases are monobasic or polybasic acids or acidic bases are taken, then we have to convert that into normality. Now, here they have given 0.001 molar barium hydroxide. What is its normality, friends? The normality of barium hydroxide. What is its acidity? 2. Because it has 2 OH minus ions. 2 into molarity. Therefore, 2 into 0.001. That is equal to 0.002. I am also writing it as 2 into 10 power minus 3. 2 into 10 power minus 3. We got the normality of the barium hydroxide. 2 into 10 power minus 3. So, after that we get the pOH. The pOH is minus log 2 into 10 power minus 3. Minus log 2 into 10 power minus 3. Therefore, we write, if we rearrange it, how do we write it? This is 3 minus log 2. 3 minus log 2. What is log 2 value? Approximately 0.3. You can take it. So, 3 minus 0.3. That will be how much? Approximately it will become 2.7. We got POH. So, 2.7 is not the answer. What they have asked is pH. So, be careful. Therefore, what is the relation between pH and POH? The relation between pH and POH is pH plus POH is equal to 14. Therefore, pH is equal to 14 minus POH. That is 14 minus 2.7. That is equal to how much? We are going to get 11.3 as the right. So, what is the right answer? 11.3. Option A. Let's go for the next question. The pH of, this is also related to pH of strong acids and strong bases only. Look at the question. pH of 1000 cc or 1000 ml of solution is 2. It will not change. So, that means we have to see all the options. Option A. If 100 ml of water is added to it, obviously what we are doing here, dilution. So, obviously the pH change takes place. Therefore, option A is wrong. So, here we have a solution of pH 2. A solution of pH 2. To this we are adding water. Obviously, pH increases. pH increases. There is pH change. Let's go for option B. They are adding 100 cc of 0.1 molar HCl. 0.1 molar HCl. First of all, here pH 2 means what is its concentration? Let's see. How do we calculate concentration? pH is equal to 2. Then what is the concentration of H plus ions? That is written as 10 power minus pH. That is 10 power minus 2, 0.01 molar or normal. For H plus ion, it is molarity equal to normality only. That means we are taking 0.01 molar HCl solution. To that we are adding how much? How much we are adding and what we are adding? To that we are adding 0.1 molar HCl. That means there is difference in concentration. So, to the 0.01 molar solution, if you are adding 0.1 molar solution, obviously there is pH change. Therefore, option B also wrong. Option B also wrong. Now, what is the next option? The next option is, they are adding 100 cc of N by 100 HCl. What is N by 100 means? What is meant by N by 100? N by 100 is nothing but 1 by 100 normal. N by 100 means 1 by 100 normal. That is 0.01 normal. What is the solution initially we have? The pH 2. That means what is its molarity normality here? That is 0.01. What is the solution we are adding? 0.01. That means to the 0.01 normal solution, if you add the same solution, 0.01 normal, there is no change in concentration. If there is no change in concentration, there is no change in pH. Therefore, option C is the suitable option. Let's go for option D also. So, obviously, they are adding 1 cc of 0.1 molar HCl. Again, they are doing, okay, they are adding a solution of different concentration. Therefore, so if you take a solution of pH 2 or if a solution of concentration 0.01 normal, if you add the same type of solution with same concentration, then there is no change in the pH. Therefore, what is the right answer? The right answer is C. Let's go for the next. Now, here we are mixing an acid and base. So, we are mixing in fact a strong acid and a strong base. Now, what happens to the pH? Let us see. Look at the question. The pH of a solution obtained by mixing 50 ml of 1 molar HCl and 30 ml of 1 molar NaOH is. That is the question. Now, if you see the question, here it is, we are mixing acid and base. Therefore, we have a principle for that. We have a formula for that. So, I am writing that formula. If an acid is a strong acid and strong bases are mixed, the N mix is equal to modulus of NaVa minus NbVb divided by Va plus Va. Modulus of NaVa minus NbVb divided by Va plus Vb. What is Na? Normality of acid. What is Va? Volume of acid. What is Nb? Normality of base. What is Vb? Normality of the base. Volume of the base. What is Va, Vb? I have already given. What is N mix then? Here, why we are taking modulus and why we are doing subtraction? Because there is a chemical reaction between acid and base. Normal mixing principle that we know, M1 V1 plus M2 V2 divided by V1 plus V2 or N1 V1 plus N2 V2 divided by V1 plus. If same type of solutions. If an acid is mixed with acid, we can use that principle. But here we are mixing acid and a base. Then what is here? NaVa. Let me write first. Here What is normality of HCl? Normality of HCl is molarity of HCl only, because n factor is 1 for that. Therefore, I am taking the same value 1. What is volume of acid HCl? That is 50. That means we are adding 50 equivalents of milli equivalents of acid, and then NBVB is how much? What is normality of NaOH? Molarity of NaOH, same value I am adding 1. And what is the volume? 30. Therefore, 30 we are getting. So, which is higher in value here? Here NaVa value is greater than NBVB value. Then what is Nmix here? There are 3 clauses here I am writing. Do look at here. If the Nmix becomes the concentration of H plus ion in the mixture, if NaVa dominates or greater than NBVB. That means if acid equivalents are more, the Nmix is the H plus ion concentration in the mixture. Now the Nmix becomes the OH minus ions concentration in the mixture if NaVa is less than NBV. That means if base equivalents are more, the Nmix becomes the OH minus ion concentration in the mixture. The Nmix becomes the H plus ion concentration, which is also equal to OH minus ion concentration. That means if both acid equivalents equal to base equivalents, if both acid equivalents equal to base equivalents, the Nmix is now H plus ion concentration equal to OH minus ion. What is the meaning of it? Complete neutralization takes place. In a neutral solution, H plus ion concentration is equal to OH minus ion concentration. Then what happens to pH? We can directly tell what is the pH of a neutral solution. pH 7. Now let us go for the problem. Here NaVa is 50, NBVB is 30. That means 50 is greater than 30, that we know. So NaVa dominates NBVB. Therefore, what happens to the Nmix now in the above problem? That is equal to H plus ion concentration in the mixture. That is equal to NaVa minus NBVB. Once again I am writing divided by Va plus Vb. Divided by Va plus Vb. NaVa is how much? 50. NBVB is how much? 30. What is Va plus Vb? That is 50 ml plus 30 ml. That is 20 divided by 80. What is 20 divided by 80? 0.4. So, we have got the H plus ion concentration in the mixture as 0.4. H plus ion concentration in the mixture as 1 by 4. Okay. Then what is the pH formula? So, pH is simply minus log H plus ion concentration in the normality. So, that is minus log 1 by 4. What is minus log 1 by 4? Can we write it as log 4? Yes. So, what is log 4 value? 0.6. So, what is the right answer? Option A. Log 4, 0.6. Are you clear with this? This is the mixing of an acid and a base. Let us go for the next problem. The degree of dissociation. This problem is related to the degree of dissociation. So, you know that the Arrhenius equation and Ostwald's dilution law. Suppose I am writing if a weak acid Ha is dissociating to give H plus and A minus. Let us take initially concentration of acid is C and this is 0, 0. Let us take C alpha is dissociated. Then what is produced? C alpha and C alpha. Then what happens to Ka? You write that is equal to concentration of H plus ion into concentration of A minus divided by concentration of Ha. That we know it. Now what is concentration of Ha remaining? That is C minus C alpha at equilibrium. C minus C alpha, because C is initially taken, C alpha is reacted. Therefore, Ka expression we have got, the Ka value is concentration of H plus ion C alpha into C alpha divided by C into C minus C alpha. So, that Ka now it is C alpha square C square. C if you take common, it will become 1 minus alpha. 1 C will be cancelled. Finally, we will get an expression for Ka. C alpha square divided by 1 minus alpha. Ka is C alpha square divided by 1 minus alpha. Generally, alpha is neglected if its value is less than 0.05. If alpha value is less than 0.05, if alpha is less than 0.05, then we neglect the alpha value. 1 minus alpha value is taken to be 1. Then what happens to Ka? Simply C alpha square. This we know. Arrhenius equation and also Ostwald's dilution law. And what is alpha value? Here Ka is directly proportional to alpha square. Alpha is degree of dissociation. Now come to the problem. For two weak acids A and B, The ratio of their percentage ionization or degree of ionization or degree of dissociation is 4:9. Then ratio of their Ka would be, by looking at, we will understand that Ka1 divided by Ka2 is equal to alpha 1 square divided by alpha 2 square. Now, what is alpha 1 by alpha 2? 4 by 9. Means this is 4 square divided by 9 square, that is 16 by 81. 16 by 81 or 16:81. So, what is the right answer? That is 16:81. So, this is the problem related to degree of dissociation. Let us go for the next problem. Let us see the next question. This question is about salt hydrolysis. Here, if any question is asked on pH of a salt, then first you have to know what type of salt it is. If it is salt of strong acid, weak base, we have one formula. If it is salt of weak acid and weak base, we have one formula. If it is salt of weak base and weak acid and strong base, we have another formula. So, let me give all those formulas as a revision. Suppose if you take salt of strong acid and weak base. So, obviously acid is stronger, means pH will be less. So, the formula of pH for that one is 7 minus half pKb plus log C. Weak base, right? pKb will get. If it is salt of weak acid and strong base, so base is stronger, therefore obviously pH will be greater. So, pH is equal to 7 plus half pKa plus log C. If both are weak, we know that important formula. So, that is salt of weak acid and weak base. If both are weak, what happens is, the pH formula is pH is equal to 7 plus half pKa minus pKb. That means here we do not have the concentration in the pH formula. So, the pH of salt of weak acid and weak base is independent of concentration. Now, this is 7 plus half. What is pKa of acid here? Look at the problem. If pK of acetic acid and pKb of ammonium hydroxides are 4.76 and 4.75 respectively, what will be the salt of ammonium acetate solution? This is actually the salt of weak acid and weak base. So, the pKa value is 4.76 and pKb value is 4.75. That means, if you substitute the data, this is 4.76 minus 4.75 respectively. Then what happens? 7 plus half. What is 4.75 minus 4.76 minus 4.75? That is 0.01. Now, this is 7 plus 0.005 will get. So, what is its value? 7.005. So, that is the right answer. Therefore, what is the option? The right option is option B. You get like this. Let us go for the next question. So, this is also about the salt hydrolysis. This is a little tricky about the practical chemistry, but let us see what is this, what is happening in this question. Look at the question. 0.1 molar NaOH solution is titrated with 0.1 molar 20 ml of monobasic acid HA. It is monobasic till the end point, and Ka of the acid is given as 6 into 10 power minus 6, and the degree of dissociation HA is very small compared to the unity. Alpha is neglected or H is neglected. What is the pH of the resulting solution at the end point? So, that means at the end point obviously we will get the salt. What type of salt it is? Here NaOH is a strong base and HA is a weak acid. Then what is the formula? Let us write first. What is the formula for pH? The formula for pH of salt of strong base and weak acid is strong base. So, 7 plus half weak acid, therefore pKa plus log C. This is the formula. Then what is log C? C is concentration. So, what is the concentration here? The concentration of the salt. Here actually they run down a chemical reaction or a titration. So, what is happening? How to calculate the concentration? Let us see. So, the chemical reaction is NaOH react with HA produces NaA, the salt, and then H2O. This is the chemical reaction. Now, how the chemical reaction takes place? 1 mole of NaOH react with 1 mole of HA produces 1 mole of NaA. Then, if you go for millimoles, what is millimoles? How do we calculate millimoles? Millimoles are calculated as molarity into volume in milliliters. Suppose I am taking the MV of NaOH. If 1 mole is reacted, produces Mv, 1 mole of HCl react with Mv and produces Mv. So 1 mole of NaOH, the molarity into volume, you know how to calculate number of moles, molarity into volume in liters. Molarity into volume in milliliters becomes number of millimoles. So Mv of NaOH 1:1. Mv of HCl react produces Mv of the salt, and water is actually the medium, therefore I am not counting that. Now what is molarity of NaOH? Here it is 0.1. What is the volume of NaOH? That is actually we don't know, that is interesting. What is molarity of HCl? 0.1. What is the volume? 20. As we know that at end point complete neutralization takes place. The number of moles or number of millimoles or the number of milli-equivalents if normalities are given. For an acid is equal to number of milli-equivalents of the base. If 1:1 ratio they are reacting. That means here this is also we have to take it as 20. That means for 20 ml 0.1 molar in HCl there is 20 ml NaOH requirement. That is the key point in this problem. So 20 ml of NaOH 0.1 molar react with 21 ml of HCl. That means 2 millimoles. Okay, react with 2 millimoles. Then what it is produced? The producer one initially it is 0. Therefore, producer one will become now 2 millimoles. Now, what is remaining? Mixture contained. This is 0, 0 because complete neutralization takes place at the end point, and this is 2. That means at end point, we have 2 millimoles of salt. I hope we are clear with this. 2 millimoles of salt we have. Now, what is salt concentration? We can directly take 0.2 or something. No, we should not take like this. Concentration, how do we know it? That is number of millimoles if you take it. Number of millimoles by volume in milliliters. How many millimoles are there? 20. Now, what is volume in milliliters? So, again, another mistake people do here. They take 20. 20 not the answer. For 20 ml of acid, we have used 20 ml of the base. So, 20 plus 20, how much it is? 40. That is the very, very important point. So, what is the concentration? Actually, 1/20. Concentration is actually 1/20. So, in this formula, we have got concentration as 1/20 and then R 0.05. What is pKa value? pKa value is how much? We need to do it. The pKa value is Ka given, that is 6 into 10 power minus 6. Then pKa I am writing here. Let's go. So, Ka is 6 into 10 power minus 6. Then what is pKa? pKa is 6 minus log 6 we are going to get. 6 minus what is log 6 value? 0.78 something. We can take approximately 0.78. Therefore, what is this value? We are going to get 5.22. So, pKa value we are getting it as 5.22 approximately. 5.22. Now, if you substitute the data, so we are going to get 7 plus half. What is pKa value? Approximately 5.22. 5.22 and then 5.22 plus log C, log 1/20. So, that is 7 plus half 5.22. What is log 1/20 value? Log 1/20 value is minus log 20. Minus log 20. What is log 20 value? 1.3. So, this will become approximately minus 1.3. Minus 1.3. So, if you substitute, if you take this, then we are going to get 7 plus half 3.92, that is 1.96 approximately. That is 7 plus 1.96. So, finally, the answer is 8.96. What is 8.96? What is the option here? Yeah, we have 8.95. So, approximately we are going to get as 8.95. Option D is the right answer. So, this is the titration principle, and here we are doing a titration of a strong base with weak acid. At end point, we will get the salt of strong base and weak acid. For weak acid, we have pKa, and concentration calculation is very important here. So, be careful when you do the problem. Let's go for the next question. The next question is about buffers. So, which one of the following mixture does not act as a buffer solution? That is the question. And the option A is boric acid. Boric acid is H3, BO3, and then borax, Na2, B4O7, 10H2. So, boric acid is a weak acid, and we have a strong base salt, that is borax. Therefore, obviously it acts as a buffer in option A, right, it acts as a buffer. Let's go for option B, what they have mentioned. sodium phosphate, okay, Na3PO4, we got the salt. And then we have sodium hydrogen phosphate, disodium hydrogen phosphate, that is Na2HPO4. Okay. So actually what is a buffer? Generally we take a buffer is a solution that resists the pH change, and then we have simple buffer and mixed buffer. Mixed buffers have acid and its salt of weak acid and its salt of strong base, or weak base and its salt of strong acid. Here in this they both look like salts, but here a buffer is actually an acid and its a weak acid and its conjugate base. Like that also we can define. So here we can take HPO4, an ion is there, and then PO4, 3 minus ion is there. So look at this. This is an acid and its conjugate base. This is the weak acid and its conjugate base. This also act as the buffers. So look at this. After losing proton, it converted into phosphate ion. So phosphate ion is a conjugate base and HPO4 minus is a weak acid. A weak acid and its corresponding strong conjugate base. So look at this. So this is HPO4 minus, act as a weak acid. It is amphiprotic substance. In fact, it gains proton, loses proton. And then its conjugate base, strong conjugate base. So it is also acting as a buffer. Let's go for option C. Sodium propionate and propionic acid. Directly we can say it also acts as a buffer. Now let's go for option D. They have mentioned sodium acetate and sodium propionate. Look at, both are salts, at the same time both are salts of different acids. How can it act as a buffer? Therefore, that is not the answer. So which of the following does not act as a buffer means here the option is option D. Sodium acetate and sodium propionate. Let's go for the next question. The next question is about obviously the last topic in ionic equilibrium, the solubilities and solubility product. Look at the question, what it is mentioned. The question is, the solubility of AB2 is 0.05 gram per 100 ml at 25 degrees Celsius. Calculate KSP of the salt AB2. And they have given atomic masses of A and B. This is a lengthy problem, but we know how to calculate solubility product. So here this is AB2 is in equilibrium with A, suppose 2 plus and 2B minus. Let us take this as the electrolyte. 1:2 electrolyte, right? So aqueous and then aqueous. Here 1 mole of this, okay, if it has, 1 mole cation is there and we have 2 mole anion is there. What type of electrolyte it is? 1:2 type of electrolyte. First let me give the expression for solubility product. Here solubility of the salt is S if you take it, then S moles or S molar A2 plus is there and 2S molar B minus is there. What is KSP expression? The KSP expression is A2 plus into B minus square. So KSP is now S into 2S whole square. So KSP is equal to 4S cube mole per liter cube or molar cube. So this is the expression we are going to get. KSP is equal to 4S cube. Then the biggest point is here, what is S here? Did they give S value directly? No. S is nothing but molarity. What is molarity of formula? Molarity formula is weight of solute AB2 divided by molar mass of solute AB2 into 1000 divided by volume of solution in milliliters. We can take it like this. Are you clear with this? Solubility is nothing but molarity here. What is weight of AB2? What is weight of AB2? It is mentioned to look at 0.05 grams. Okay, it is mentioned 0.05 grams. Okay. What is molar mass of AB2? Molar mass of AB2, it is given like this. They have given atomic masses of A 20 and atomic mass of B is 40. That means AB2 means what is molar mass? That is 20 and B2. This is 40 plus 40. Total 2 atoms of B. Total how much we are going to get this as 100 gram per mole. So what is the molar mass of AB2? 100 gram per mole. Therefore, we are going to get this as 100. We are going to get this as 100. And then what? 1000. What is the volume of the solution? The volume of solution they have mentioned it as 100 ml. So if you simplify this, you will get the solubility. So 100. Okay, now if you simplify this, what we will get about? So this will be around 0.05 into 10 power minus 1. Finally, we are going to get 5 into 10 power minus 3. This is the solubility value. Then what is KSP? Then what is KSP? The KSP is 4S cube. KSP is 4S cube. Therefore, 4 into what is S value? 5 into 10 power minus 3 whole cube. Then what happens? 4 into 5 cube is 125 into 10 power minus 3 cube, 10 power minus 9. 500 into 10 power minus 9. This value becomes 5 into 10 power minus 7 mole per liter whole cube we are going to get. So, what is the right answer? 5 into 10 power minus 7. So, we will get option B as the right option. This is the calculation of solubility product, but they have given data. So, we need to correlate the data and substitute the data properly to write the right answer. Let us go for the next question. It is about the common ion effect. This question is about common ion effect. That we know that what is common ion effect? Common ion effect says that the degree of dissociation of a weak electrolyte is further suppressed by adding a strong electrolyte of having common ion. That means here, in case of solubility equilibrium, the solubility of a sparingly soluble salt AgCl is further suppressed by adding a strong electrolyte contains either Ag plus or Cl minus. We can suppress this, we can reduce it. Now, the question is the solubility of AgCl will be maximum, they have asked, not minimum, maximum in which of the following question? Following they have given. In case of KCl, there is common ion, what is that? Cl minus, therefore obviously solubility is less. In case of HCl, what is the common ion? Cl minus, obviously solubility is less. In case of AgNO3, what is the common ion? Ag plus, obviously solubility is less. Then the solubility is more in case of deionized water. In pure water, sparingly soluble salt solubility is more because there is no common ion effect in pure water. If common ion effect is there, the solubility is decreased. But here, in case of pure water, there is no common ion effect. Therefore, what is the right answer? The right answer is deionized water. So, that is the end of the different models that are covered in Ionic Equilibrium chapter. Thank you very much.